Okay, we're going to go ahead and get started. I want to welcome you to the Stormwater and Transportation webinar, the first of our three-part webinar series here. And it's Thursday, the 28th of April. And today we're going to be talking about construction effluent guidelines. Numerical effluents are coming. My name is Eric Strecker. I'm with Geosyntec Consultants in Portland, Oregon, and I'm pleased to be with you today to moderate the session. The session is sponsored by the Center for Environmental Excellence by AASHTO. It's in cooperation with the Federal Highway Administration and the Federal Transit Administration. This is the first of three upcoming stormwater webinars. Others are being organized for the June and July timeframe, and the tentative topics for those are in June are environmental management systems for stormwater compliance, and in July, post-construction BMP selection and design to meet numerical objectives. We may change the titles there a bit, but that's generally what we're looking at. So today's talk is going to be on the, as I mentioned, construction effluent guidelines. Numerical effluents are coming. We're going to provide an overview of the changing construction site requirements that are out there, specifically the national effluent guidelines that have been published, and then discuss with those the relevance and implications for linear systems. And then we're going to have two talks that talk about approaches to meeting numeric effluent limits or benchmarks, one around active treatment systems, and then another talk on more of a passive BMP approach. So today's speakers are Jesse Pritz from the United States Environmental Protection Agency, and he'll be giving us an overview of the construction effluent guidelines and some implications for transportation agencies. Elsa Pierski from Washington State Department of Transportation is going to talk about active treatment systems and their use in Washington State. And then David Harris from North Carolina will be talking about passive treatment of construction effluent in North Carolina. So each of our speakers are going to have about 20 to 25 minutes for their presentations, and at the end of all three talks we'll have a question and answer period. And you can submit questions via the go-to website or the go-to bar that's up on your screen. In addition, there's going to be some polling questions that I'll put up as well. And then as of just before we started, we had about 280 sites registered, and I'm seeing right now about 168 sites. Someone else is just joining as we started talking here. So with that, I'd like to introduce Jesse Pritz from the U.S. EPA, and he'll be giving us an overview of the effluent guidelines that they recently published.
Thanks, Eric, and hello, everyone. I'm glad to have the opportunity to talk to everyone today about the construction effluent guidelines. So the presentation that I'm going to give today, I have a couple of things I want to talk about. The first thing is to just give everyone a little background on effluent guidelines in case you're not familiar with what they are and how they're developed. Talk a little bit about what the guidelines are and what they aren't, what they do and what they don't do. Give a little history of the rulemaking for those that might be interested in how we arrived at where we are right now. Also talk a little bit about some recent litigation and some court activities and some actions that we're taking right now in terms of applicability of and timing of the turbidity limitation, which I'm sure everyone is very interested in. And then I'll talk a little bit about the specifics of the rule, the non-numeric requirements, the numeric requirements, and finally I'll give a little perspective and some points on things that I think are particularly relevant or special considerations and special challenges for departments of transportation and linear projects. So a little background. Effluent guidelines, what are they? If you don't know this, they may be sort of a new concept to you, but quite simply, effluent guidelines are what we call categorical discharge standards, and by that we mean that they apply to specific categories of dischargers under the Clean Water Act. We've done effluent guidelines here at EPA for most of the heavy industries in the country, so we have guidelines for iron and steel manufacturing, chemical manufacturing, et cetera, but we've also done a few guidelines that are more non-point source or stormwater related, including the construction effluent guidelines. They're nationally applicable requirements. That means they apply to everybody that's required to get a permit. So these are not rules that just apply in areas where EPA issues permits. These rules apply to the whole country. And the rule itself, effluent guidelines, are minimum requirements for all projects. In the case of the construction effluent guidelines, that includes a number of non-numeric requirements, best management practices or erosion and sediment controls, as well as some specific numeric requirements for turbidity that apply to certain types of construction activities. So I'll talk a little bit about that. What effluent guidelines are not is that they are not risk-based, and by that I mean they do not vary based on the quality of the receiving water. So they are not tied at all to the background level of the receiving water. And because of that, they don't replace more stringent water quality standards. So, for example, some projects may be subject to more stringent water quality-based standards for the specific streams than what the effluent guidelines would put in place. And they don't replace any more stringent standards. So, for example, some states have existing requirements for monitoring and existing action level requirements, for example. So the effluent guideline doesn't replace those. They're just minimum requirements, and it doesn't prohibit the states from being more stringent than what's contained in the effluent guidelines. And they don't apply to discharges after construction is complete. They only apply during the active phase of construction. Incidentally, EPA does have another rulemaking going on right now that's intended to address the long-term stormwater discharges. I can't advance the slide right now because Eric, it looks like there's a poll question up, and I can't actually see the slides. There we go. So a little bit on history. EPA first promulgated some effluent guidelines for this category way back in 2002, and those rules were mostly narrative requirements. We didn't include any specific turbidity limitations or monitoring requirements in those rules. But we decided for a number of reasons not to finalize that rule in 2004. We were subsequently sued by a couple of environmental groups and a couple of states over our failure to issue those rules, and subsequently the court ordered us to take further action and to propose a new rule in 2008 and finalized by December of 2009. And we met that deadline, so that we did promulgate a new rule in December of 2009. Now, I mentioned that there's some recent activities here at EPA related to the turbidity limitation, and specifically we were sued over that 2009 rule, and we also received some petitions from several entities to reconsider the numeric limitation. And there were a number of issues brought up in that litigation and petition, but the main issue was the data that we used to calculate the turbidity limitation. So we decided that the petitioners and the plaintiffs had some valid issues. So earlier this year, we issued a stay of the numeric limitation, and we're currently in the process of reproposing a new turbidity limitation. So that stay only applies to the numeric requirements. It doesn't address any of the non-numeric requirements. So all of those requirements are still currently in place. And as I mentioned, the rule was published in December of 2009 and became effective in February of 2010. So what that means is any permit that's issued by EPA or any state after February of 2010 must include all of those non-numeric requirements, but they do not have to include the numeric requirements until we issue a new rulemaking. So our current plan is to propose that new rulemaking later this year, and maybe within the next few weeks or months. There'll be a public comment period on that new rulemaking, and specifically on the turbidity limitation. And there are a couple of other issues as well that we're likely to discuss and solicit comment on. And then after that public comment period ends, we'll take action to issue a final rule with a new numeric limit. And that, I'm guessing, will probably come out towards the end of this year, perhaps early next year. But it all depends on how many comments we receive and if we receive additional information that we need to consider. So the applicability, I mean, what does the effluent guideline apply to? Specifically, it applies to all construction sites that are currently required to obtain a permit, and our national regulations that we promulgated a while ago, the Phase 1 and Phase 2 stormwater regulations, require that any construction site that disturbs 1 or more acres of land has to get a permit. So the national effluent guidelines apply to that same population of permittees. We don't bring anyone else in to the current permitting program. It applies in all 50 states as well as the tribal areas in the U.S. territories. Now, EPA, we still issue permits in 4 states as well as the District of Columbia and certain territories and tribal states. All the remaining states and areas issue their own permits, so each of those states will be required whenever they issue new permits to put the requirements in. And because of the fact that states issue their own permits, the specific applicability dates or when this is going to make it into a permit is likely to vary across the country, depending on when states have issued their most recent permits and when those permits are up for exploration and renewal. And it applies to all sites that are required to obtain general permits, but it also requires the sites that are covered under individual permits. There aren't a whole lot of individual permits issued across the country compared to general permits, but there are quite a few that are issued specifically for more complicated projects, or if there's a specific location or site-specific issue, it may apply. Might have to get coverage under an individual permit. And another important thing is that the guidelines will apply not only to new sites but also existing sites, because basically when a permit expires and that permit is no longer valid, any ongoing construction activities will need to apply for coverage under the newly issued permit. So even though you have a site that may be ongoing when those new permits are issued, they will be subject to the new requirements in the permit. So it's something to consider in terms of upcoming projects and planning, that there's a potential that depending on when states issue a new permit, the new turbidity limitations may apply to those existing projects as well. So what does the rule specifically require, and what's it's going to change, and what's going to be different from what you're already required to do for your construction activities? I mentioned that there's sort of 2 sets of requirements, the erosion and sediment control or non-numeric requirements, as well as the turbidity limitation. And there are actually quite a few of these non-numeric requirements that will now be minimum requirements for all the state permits. And there's several broad areas that we've categorized these new requirements. So the new rule contains some minimum requirements for erosion and sediment controls. There's some pollution prevention requirements. There are some new soil stabilization requirements that are different than what different than what may be in your current permit. There's also some categories of prohibited discharges. There's a new requirement for using surface outlets for any discharges coming from basements or other impoundments. And what it's also likely to change is states' consideration of the use of chemical treatment, passive treatment, active treatment, polymers, and other flocculant aids. Given the nature of the numeric limitation, it's likely that many projects are going to need to employ some sort of polymer or flocculant in order to meet the turbidity limitation. So that's something that likely will be some new requirements that folks haven't seen before. What it doesn't change, as I mentioned before, is who has to get a permit. We don't broaden the scope of the current regulations. So we don't bring anyone new in. We don't exclude anyone. It doesn't change any of the permit application requirements in terms of what you need to do to get permit coverage for your project. It doesn't, as I mentioned, change any existing requirements or benchmarks, et cetera, that you may be subject to. And it also doesn't change what you need to do to terminate permit coverage, how you file for a notice of termination for your specific projects. So on this slide, I've highlighted what I would characterize as the major changes to the non-numeric requirements that may not be part of your existing state permits. But there are actually quite a few specific provisions that are contained in the rule. So don't take this slide as the comprehensive list of the new requirements. I'd really encourage you to go look at the actual rule itself on the EPA website, and you can get a listing there of all the specific requirements that are now minimum requirements. But some of the things that I would characterize as the major changes, and the first of those is a requirement that vegetated buffers be implemented on all projects adjacent to surface waters. Now we have some exceptions to those requirements, and the states will have some flexibility for how they set those requirements, but it is now a minimum requirement to maintain some sort of vegetated buffer. Encouraging and requiring the use of dispersion of your discharges to vegetated areas, if feasible, is another specific requirement. So taking advantage of the vegetated areas on your site as areas that can receive the stormwater discharge. Soil stabilization requirements, some new requirements for how much time you have to initiate soil stabilization activity, portions of the site that you've stopped working on that have reached final grade or aren't going to be worked on for a while. And I mentioned some prohibited discharges, and an example of one of those is limitations on the discharge of things like concrete washout and other wash waters that may be produced on your site. And I also mentioned the requirement for surface outlets for only the final point of discharge, so it doesn't necessarily apply to intermediate impoundments used within your site. But if you're discharging out of a basin or a trap or anything, and that's the final discharge point or points from the site, there is some general requirements to use some sort of surface outlet for those discharges, and there's some flexibility built into that as well, and that's a key concept that I talk about is there's, as I mentioned, a pretty comprehensive list of minimum requirements in the rule, but there's also some flexibility in that for a lot of these practices and a lot of these requirements, there's language that allows you to get some relief from that requirement if you've got and you can demonstrate that the use of that practice or implementation of that control would be infeasible on your site. I think this is particularly applicable to a lot of Department of Transportation projects where you've got space constraints, or I mentioned the stream buffers. A lot of your activities take place adjacent to the streams or into the streams. So there's flexibility built into the rule, so you can consider some of those requirements and work with your state and your permitting authority on addressing those. However, that feasibility provision does not apply to the numeric limitation and the monitoring requirements. If you meet the definition and you're subject to the monitoring requirements, there's no relief from that monitoring requirement for that particular project. So the turbidity limitation itself is it's an enforceable limitation, which means that it's an actual limitation on the amount of turbidity present in the discharge. It's not an action level or a benchmark or something that would prompt you to take some additional action if you've exceeded the limitation. It's an actual limitation on the discharge of the turbidity, and if you violate that, if you exceed that limitation, then there's the potential that the permitting authority could seek enforcement actions against your project. And turbidity, you may all be familiar with turbidity, but what it is basically a measure of the clarity of the water, or how much sediment or other materials are contained within the water. And turbidity can be measured in the field, and we specifically chose turbidity for a number of reasons, but also because it can be analyzed in the field, and so you don't have to necessarily take samples and ship them off to a laboratory to find out if you're in compliance or not. And applicability, the turbidity limitation doesn't apply to all sites. It only applies to sites that disturb 10 or more acres of land at one time, and that's a key concept, the concept of at one time. So if you're able to do things like phase your construction or do other activities to minimize the amount of disturbance, then there's a possibility that your larger projects could not be subject to the limitation. And it applies at the point of discharge from your site, so that's obviously going to vary site to site, but generally any pipes or channels discharging to storm drains or discharging directly to the surface water are potential compliance points for the rule. I also want to mention, I guess since there's probably some folks that may have joined us a little late after I started, that I'm talking about the turbidity limitation and monitoring requirements on these next few slides. But as I mentioned earlier, EPA has issued a stay of the numeric limitation. So currently there is no turbidity limitation on the books, and the no requirements to monitor until EPA issues a new rule, which I mentioned we'll probably propose in the next month or two, and then take final action on towards the end of this year or next year. So this is really sort of a placeholder or a description about what the turbidity limit will be once we issue those new proposed and final regulations. So sampling, another thing that goes along with being subject to an enforceable limitation is that you have to be able to demonstrate compliance, which means that for your projects that are subject to it, you're gonna have to collect samples and show that you're in compliance with the limitation. the limitation applies to any discharge from the site, and that could be stormwater runoff, or it could be things like dewatering, or pumping out sumps and things like that. Anywhere the water is discharged to either a storm drain or directly to a surface water, is those discharges would be subject to the turbidity limitation if you meet the other applicability criteria. Now, one special provision we have in the rule, specific only to linear projects, is that the permitting authority can allow what we call representative sampling instead of sampling at each discharge point. So particularly for linear projects, and more so for large linear projects, you may have dozens or more discharge points from your construction site. So it's not our expectation that you would have to sample and demonstrate compliance with the turbidity limitation at each of those discharge points. We allow for the linear projects that for the permittee, working with the permitting authority to identify the places where sampling is appropriate. And there's also the general expectation that you don't need to sample non-concentrated points of discharge, or what you might call sheet flow. So, water that flows through a silt fence and goes into a vegetated area or a field next door and doesn't actually go to waters of the U.S., we're not anticipating that you would need to sample those types of discharge. So it's really the basins, the ditches, the channels, the pipes, those sorts of things that we're envisioning that would be subject to sampling. So how often might you have to sample? Well, that's really going to depend on the state. In the national rule, we did not include any specific requirements for either the frequency with which you need to sample or the type of samples that you need to do, whether it be grab samples or composite samples or continuous sampling with an in situ meter. And we also don't specify analytical methods for the monitoring. We're leaving all of that up to the states. Now, generally, we would expect that using a field turbidity meter and doing grab sampling would be sufficient for demonstrating compliance. And generally, we recommend, although it's not a requirement, that for a particular discharge, that you collect 3 samples per day over the course of a day. So what about exceptions? Are there any exceptions to the rule? Oh, sorry, skip one slide here. The turbidity limitation itself, how do you determine compliance? I mentioned, for example, the rule that we did in 2009 that we have since issued a stay on. The numeric limitation was 280 NTUs. So once we issue a new final rule, let's just say that the number is, for argument's sake right now, would be the same. So that would be your actual discharge value that you would have to meet. You don't consider the background level of turbidity in the receiving water. So if your background water is 1,000 NTUs, it doesn't matter. It could be 2 NTUs, it doesn't matter. The limit is the limit, and that's it. But it's not an instantaneous maximum. It's what we call a daily average. And what that means is that for a particular discharge point, you can average the samples collected over the course of a day, determine if you're in compliance. So you can have a sample that's 1,000 or 2,000 as long as the subsequent samples that you collect when averaged with that value are below the limitation. And then what are you going to have to do with this information? Well, it's an enforceable regulation, and there's probably, you would imagine, a provision that you're going to have to do something with that data. We haven't specified that in the regulation. That'll be up to the individual states. They may require you to do monthly or biweekly or every 3 months to submit that data, and they may require you to notify them if you have a discharge that's above the limitation, but we don't get into that in the rule. They may require electronic reporting. They may require paper forms. We don't really know. That's going to vary state to state. And they may have specific requirements that you have to notify them, for example, if you're above the limitation. Again, we don't specify that. That's up to the individual states. So exceptions, I want to talk a little bit about some exceptions and flexibility built into the rule. There are some exceptions to actually meeting the turbidity limitation, specifically for larger storm events. So, for example, if you have precipitation in any one day that exceeds the local 2-year 24-hour storm event, you would not need to be in compliance for that day. You would still need to collect samples, but you're not going to be held to the limitation on that day. And as I mentioned before, it does not apply to larger construction sites if they're able to phase their construction activities such that they're below 10 acres disturbed at one time. The other area that states have a bit of flexibility are some specific requirements related to the vegetated buffers. I mentioned that there's a new requirement that you have to maintain vegetated buffers around surface waters. We don't dictate or say how big they need to be. That's up to the individual states. But we do talk about some in the supporting materials to the rule about activities such as water crossings and those sorts of things that obviously you need to have some variants or different provisions for those types of activities, which I suspect will happen a lot on Department of Transportation projects. And I mentioned if you're able to stay under 10 acres disturbed at one time, you're not subject to the rule, but we don't dictate what constitutes adequate stabilization. So that's going to be up to the individual states to determine what areas do and do not count towards that disturbed acreage threshold. And there's also some flexibility in terms of arid and semi-arid areas. We recognize the complications associated with soil stabilization in arid and semi-arid areas, particularly with respect to getting vegetative stabilization in. So we do provide some flexibility that states can develop some different stabilization requirements for those areas. On this slide, I've highlighted what I think are probably some of the main challenges or issues that are going to be able to affect compliance for linear projects. And I mentioned one before, given the large number of potential outfalls, the feasibility of sampling at all those outfalls is just not feasible. So the concept of representative sampling, I think, is very important for the DOT projects. And as I mentioned, this will likely vary by project. We don't specify that in the rule. There's going to be a lot of flexibility for states to determine how many of the discharge points you would need to sample. And I mentioned the concept of stabilization. So getting any area stabilized as soon as you can means you can not count those towards your disturbed areas, and you don't need to sample those areas. So I think stabilization is going to become and rapid stabilization is going to become very important for your types of projects. Another thing I think is trying to think up front about where your potential discharge points are going to be and how you might consider the need to do sampling on those sites, and things like access to the areas I think is going to be very important. Some unique challenges for linear projects is certainly space. Most of your projects I know have limited right-of-way, so where are you going to put the technologies and that limits the types of practices that are potentially applicable to your sites. Another thing I think is important is consideration of run-on or diversion. So any water that runs onto your site is your responsibility. So, I think it's important to determine how you're going to manage potential run-on areas. I mentioned the issue of construction within water bodies, bridges and piers and those sorts of things. And the concept of multiple sub-watersheds. There are a number of projects where you may need multiple treatment systems involved, so considering where you're going to place those treatment systems is, I think, very, very critical. So a little bit on the new rulemaking we're working on. I mentioned that we issued a stay of just the turbidity limitation, and we're currently in the process of putting together a proposed rule that'll have a new turbidity limitation, so that will be out soon. As with the previous rule, we will likely retain this concept of a phase-in. So the current rule had a two-part phase-in for the turbidity limitation. Initially, it applied to sites that disturbed 20 acres, and that'll go down to 10 acres. And it's our intention to keep that same phase-in, although the dates will likely change from what was in the previous rule. After that proposal comes out, there'll be a public comment period. And then we will finalize the rule, and it will become, again, a minimum requirement that must be implemented into state permits. So I think the thing I want to leave you with, and to sort of recap, is what I see as some of the keys to compliance and how you can minimize your potential exposure to enforcement actions. I think source control is a big thing, thinking about how your construction is progressing, where your water is going to coming from, how you're going to manage that water, how to manage things like run-on is going to be critical. The concept of phasing your land disturbing activities is obviously very important. If you're able to phase, then you can potentially limit the amount of time that you're potentially subject to the numeric limit in the monitoring. Minimizing the footprint of disturbance. Maybe that's not such a key concept for linear projects because given the narrow right-of-way, I think that's probably a concept that everyone is already using, but it is important. And I think also the concept of a treatment train, so multiple controls in series, some redundancy built in so you're not relying on one specific practice at sort of the end of the ditch to manage your turbidity. And consideration of the vegetated areas on the site, how you can utilize those areas for accepting stormwater runoff from your disturbed areas, I think is really important. Stabilizing the soils, obviously, I talked about the ability to get soils stabilized and minimize the runoff generation from those areas that needs to be managed. And the concept of retaining water on site, again, it may be difficult for linear projects, but if you don't have a discharge or you minimize the number of discharge, then you're certainly limiting your exposure to the rules. And I think the issue of using polymers and chemical flocculants and other treatments is obviously going to be very important for a number of projects, particularly if you have clay soils or other things that make managing turbidity difficult. And also the concept of treating all the water. You can have a little bit of water coming from an uncontrolled area coming into your control that can really affect the performance of the turbidity coming out of that. So the concept of watching where the water is coming from, I think, is very important. And also, one thing is to sample the whole hydrograph. When you have a storm event, usually you have a period of very intense rainfall, and then it sort of tapers off, and your sediment load coming out off of your site and through your practices, I think tends to generally follow that same process. So if you're able to take samples over the course of the day and don't just get samples during that period whenever you've got intense discharge, then I think that's going to be a very important concept. So the final slide here I leave you with is to just some places you can go for more information. I mentioned that the existing rule, not the turbidity limitation, because that's sort of on hold right now, but the rest of the rule requirements are in effect, and they have to be incorporated into permits. In EPA, we just recently put out our federal construction general permit that applies in the areas where we issue permits. That's out for public comment right now, so here's the link where you can go to download that permit. And you can see how EPA has incorporated all of the non-numeric requirements of the effluent guideline into our permit. And although states don't have to do it the same way, in many cases some states tend to follow the format or the requirements of the federal permit. So it's maybe a good indicator of what future permits are going to look like. There's a 60-day public comment period on the construction general permit. So that permit was just, I think, published maybe earlier this week. So that public comment period will run for about 2 months from now. The revised effluent guideline, the revised turbidity limitation, it's not out for public comment yet, but I would say it's something that's likely going to come out in the next few weeks. You can watch the press for announcements, which I'm certain it'll certainly be in there in some of the trade information. Or you can check our website periodically to see if we've posted up information there. Once that rule is available for public comment, we'll post it there, and there will be instructions on how to submit comments on the rule. So that concludes my presentation, and thanks very much.
All right, thanks, Jesse. As I mentioned at the start of the webinar, we'll be taking questions after all three speakers have given their presentations. Just to make sure everybody's awake, I'm going to launch another poll here, this time not interrupting anybody, and which you'll see the poll now. Just trying to get a gauge on how many folks are at each of the sites, and just to give you a little preview, the next poll will be asking you the kinds of disciplines or departments that each of you are in, just so we get a handle on that. But that'll come in between the next two speakers. So we're doing pretty good. 81% voted here. Looks like most of you are doing it solo, but there are a number of folks that have multiple parties there. So I'm going to go ahead and close the poll and then move on to our next speaker, who's Elsa Pekarsky from the Washington State Department of Transportation, and she's going to talk about active use of active treatment systems for meeting numerical either limits or benchmarks. And so go ahead and take it away.
Thanks, Eric. Again, my name is Elsa Piekarski, and I'm going to be talking about active treatment systems and how they've been implemented on WSDOT projects. And I'm specifically going to be talking about chitosan enhanced sand filtration because that's really been the preferred method here in Washington State. I want to start off with looks like I can't move the slide. I don't have control yet. Eric? There we go. So I wanted to start off with a quick overview of the permit in Washington State. We just got a new permit issued at the beginning of this year. It doesn't have a numeric effluent limit in it as of now. We're still operating under benchmarks and trigger values that determine the level of water quality concern and a required level of action. So if we exceed the 25 NTU turbidity benchmark, there's action required. We have to review our SWIP, add adaptive management where needed out in the field, and then update the SWIP and make sure that the BMPs are installed. If we exceed the 250 NTU reporting trigger, we have immediate action required, same requirements for the benchmark exceedance, but we also have to notify the Department of Ecology within 24 hours. So some additional requirements there. And then we also have to take contingency sampling until the samples are either below the 25 NTU benchmark or the discharge stops or is eliminated. We do have in the new permit an option for using a numeric effluent limit for discharges that are going to impaired water bodies, so water bodies that have been identified as impaired on the 303D list. And Ecology has allowed some flexibility for managing this risk by requiring us to comply with a 25 NTU limit at the discharge point or using water quality standards. So why does WSDOT use active treatment? Well, I think mainly is the species that we have in our water bodies here. Salmonid species are sensitive to fine particulates, and so therefore our state water quality standards are quite low, and that's why our benchmark, 25 NTU benchmark, is also set low. Active treatment lowers water quality risks for work in wet and winter weather, and this means that projects can be completed faster if we're allowed to work through the wet and winter months with
Muted.
Science concern.
Unmuted.
Duration can be shorter.
Muted.
Has benefits. Benchmarks are very low in Western Washington. The 25 NTU benchmark.
Unmuted.
Also have the 8.5 pH benchmark. If the 25 NTU benchmark is exceeded, adaptive management becomes required. And what we have found is that projects that have higher risks, if you plan ahead and implement active treatment ahead of time, what we'll see is a less of a need for continual adaptive management. So there's not this continual need to put out new BMPs in the field. And so in the end, it may end up saving money or be comparable to a project that won't use active treatment. Active treatment effectively and efficiently treats turbid water on linear project where there is not room for large ponds or good areas for infiltration or dispersal into vegetated areas. And active treatment reliably meets compliance requirements for a 303D listed water body. In Washington State, potential active treatment methods are reviewed and approved by the Department of Ecology, and chitosan enhanced sand filtration there are multiple methods and products approved for conditional or general use. And I'll go into a little bit more about what that difference is. Electrocoagulation, there's currently only one treatment method approved for general use, and WSDOT has not used this method in the past. WSDOT has chosen chitosan as their preferred choice for active treatment system for various reasons. There are local sources and providers in the area. We have a big Dungeness crab populations here, lots of industries that recycle the crab shells and can provide chitosan locally. And the Department of Ecology has approved multiple products and methods for general use. And general use products have a streamlined approval process, so we're able to very quickly apply for the use or notify Ecology that we're going to plan to use a certain product or method on site, and it's been streamlined, so it's much easier to get that out in the field. It's also a preferred choice because chitosan is a natural, non-toxic, biodegradable biopolymer. It also has some natural chelating abilities, so it does seem to have a little bit of an impact on reducing heavy metals in runoff, so that's a positive as well. And this little picture here is meant to give you a basic idea of how chitosan works for those of you who aren't familiar with it. When you have long-term suspension in a water column, it tends to be because of the negative charge on some of the fine particles in the water. They just continue to bounce off of each other. And so when you add a coagulant such as positively charged chitosan product and rapidly mix it, it helps to flocculate those particles, and then they can gravity settle out and then be sent through sand filtration pods to get the last bits out. And we've seen really good performance in this technology. So a little bit more about what general use level designation means here in Washington State. Again, Ecology will designate a product or method with a general use or conditional use, and that helps the permittee figure out how they need to implement this on the site and what sort of approval process they need to go through. The general use products can very easily be applied for. There's a request for chemical treatment form. It's a simple 3-page form, or you can notify the Department of Ecology on your notice of intent form that you plan to use a certain product or method. And so it's a pretty quick, streamlined process for general use products. Some basic insight into what the documentation requires for using these general use products. There are operational monitoring forms, including equipment calibrations, treatability tests, which need to be done on a daily basis. You take a sample of your discharge and you add some chitosan to see how the discharge reacts to it, and that helps you decide how much chitosan you want to add to your influent discharge. Total volume treated also needs to be measured. There is a dosing maximum here in Washington, and we are required to do 2 residual chitosan tests within the first 2 hours that the system is in operation. If you shut down a system for a time period and you start up that same day, you are required again to take residual chitosan testing. And that is important because residual chitosan testing is intended to make sure that you're not discharging any free chitosan into water bodies. Continuous monitoring is required for influent and effluent of your water, pH and turbidity measurements. Flow rate is also something that needs to be continuously monitored. Source control is still required, and that is intended to minimize the need to pre-treat. So you really want to make sure that You're not just letting the site go and just sending really dirty water to your pond, because then you're going to need to use more chemistry, spend more time on pretreatment, and so ecology has required that source control is still required even if you are using chitosan enhanced sand filtration. You need dedicated pretreatment holding tanks or ponds, and there is a maximum effluent limit of 10 NTU for chitosan enhanced sand filtration, and that is because chitosan attaches itself to the sediment particles, and so the 10 NTU limit is again another way of preventing chitosan from discharging into water bodies of the state, and it can have a negative impact on the residual chitosan testing. And these systems need to be operated by certified CESF technicians. So some real basic kind of pros and cons. Pros, compliance assurance. It's you just have a lot of confidence that you're gonna be in compliance and stay in compliance. Especially here in Washington, we have a lot of we have a long wet season, and working through winter, if there's any sensitive areas, it's really nice to have that assurance. Smart water management. We have found that depending on the nature of the project, sometimes there's groundwater that gets turbid, there's stormwater discharge that's turbid, and you can design your systems either as a stationary system or a mobile system, and you can really route water around and treat water coming from different areas. And we've also seen increased discharge rates with minimal sediment release, so very high performance in these systems. Cons, obviously, these systems are fairly expensive, but we at WSDOT are still trying to perfect the bidding and speccing process for this. We've implemented about 18 to 20 systems through statewide, and we're still perfecting that process, and we are getting costs down. Increased time commitment to design and planning. If you want to have a well-run system at a good price, it really does take that commitment to design and planning. The footprint needed for these systems is another challenge on linear projects. Having access to areas for large ponds can be a challenge, especially in urban areas. So we have seen a lot of projects using mobile tanks, but that is definitely a challenge, having the footprint for those systems. And another difficulty is because of the linear nature of our projects, sometimes a stationary system that is in one place, it can be difficult, because as we're phasing and moving down the line, we need something that we can move around easier, and that can be kind of expensive. Okay, there we go. So this is a sort of a case study to a project. This was a two-system project. It was used about 100 times in a little under a year. Total cost, you can see, was about $1 million, but that was a bid as a lump sum system, which we've sort of gotten away from, because there are known costs with implementing these systems, and we found that if we break up those known costs, we can get a better price. This system ended up only using about 6% of what they estimated they were going to use it for, and so that's one of the things that we've tried to incorporate it into our new bidding process, is to do a better job of estimating how often we're going to be using this system and how many gallons of water we expect to be treating. About halfway through the project, it was realized that the contractor was able to utilize a sanitary sewer permit, And so they were able to get rid of quite a bit of water on a daily basis to that system. And if that was known beforehand during the planning process, that would have lowered the bid amount for that project. So some planning and design basics. It's really important to review geotech reports, know where your groundwater level is, soil type, know if you're going to have clays, colloidals, fine silt. Evaluate site-specific factors. You want to understand climate patterns, basin area, if you have areas for infiltration. Evaluate project-specific risks. It's important to understand where your sensitive areas are, what your discharge water bodies are they impaired water bodies, and whether your project is going to be working through the winter and what your project duration is. Determine your treatment needs. You want to consider whether contamination might be an issue. There are ways of adding additional treatment methods to these Kaizen systems. You can put activated carbon filters to the end, create like a treatment train type system where the water goes through several different types of treatment. You also want to do a hydraulic analysis to help understand how much water you expect to be collected or how much groundwater you expect to come into contact with. All of these planning methods can help you also determine whether or not a mobile or a stationary system might be more appropriate for your project. A lot of projects at WSDOT have sort of implemented both, where we have one large pond where we route a lot of our water to, and that's sort of a stationary system that's used throughout the project. And then they also supplement that with a mobile system. This picture here shows what a mobile system looks like. And these systems aren't as efficient. They don't get rid of as much water as one of these larger stationary systems, but they're really handy to move around through the project if you have little collection areas or areas of water that you just need to treat. You know, maybe you just need to have the system running for 3 hours in one location. And so we've seen that as a technique that a lot of projects have been using. It's really, really important not to skip conventional BMPs. Again, you are required in Washington State to continue to use source control BMPs, but it really is important because these systems run much more effectively and efficiently if your water that you're sending to your sand pods is below 600 NTU. And also we have found that PAM doesn't work well when you have it in some water that you're trying to treat. It lowers the effectiveness of chitosan. So try not to mix chitosan and PAM. And it's important to plan for extreme events and have a contingency plan. So if a system's planned ahead, we do include these systems in contract language with some specifications. And again, WSDOT has been changing how they do that. They started off just sort of bidding these lump sum, but we have found that it's been more effective, more cost effective to kind of break out known values. So we've learned to specify quantitative estimates by breaking up the known values. For example, operational estimates can be made based on hydraulic analysis. Equipment and hourly operational costs are known values. So again, figuring out how much and what type of equipment you're going to need and how many hours of operation you expect that you're going to need based on the hydraulic analysis, how much water you think you're going to be treating. Historically, systems have been installed and operated by specialty subcontractors, but that has meant a 10 to 40% markup for WSDOT. And so recently, contractors have been buying and operating their own systems, and this has lowered markup costs, but we have seen that these systems tend to be older, less advanced, or run less efficiently. And so in the end, that has raised operational costs. So it's been kind of a wash as far as, whether it's a specialty subcontractor or a contractor that owns their own system. It is important that if you have a contractor that's bought their own system, to make sure that whoever is operating the CESF system is certified. And in Washington, that's part of the general use requirement, that the systems are operated by certified folks. And it is important to our inspectors, our WSDOT folks are keeping an eye on these systems and making sure that discharges are maintained below a 10 NTU discharge limit. So cost summary, these costs vary widely, and that's partly because of the fact that it's a pretty new technology and we're still sort of figuring out the best way to bid these things, and there has been a change in who provides these types of systems, whether it's first, second, or third tier contractors. Other factors that affect costs are the planning process, whether the system was planned for in advance or if it was more of an emergency situation where construction already started and we realized that we really needed to get some active treatment out there. Again, the complexity of the system, how many systems you have, how much piping is required, whether there's contamination issues, and also how the bid breaks down system operations, for example, pre-treatment, maintenance, operations, and whether that ends up to be a lump sum bid or something that's broken into pieces. Operational efficiency, so how efficient is that system run? How much time is spent on pre-treatment? Are the operators experienced? These systems can be finely tuned, and because it is a system that works with pressurized sand pods, sometimes there's things that experienced operators can do to increase the performance rather than just simply adding more chemistry. And so we have seen in some cases with less experienced operators that they just raise the amount of chitosand that they're adding to the water rather than finely tuning the system itself. Whether the system needs to be remobilized during construction. Again, if you have a stationary system set up for 6 or 7 months and then due to project phasing you need to move it, there's a lot of cost associated with moving these systems. So if you have a long project or you have several phases, you may want to consider a mobile system that's more able to move around. Monthly costs for one system generally range from $10,000 to $30,000, again, really depending on the complexity of the system. But a well-planned, efficiently run system, you should expect to pay about 3 to 5 cents per gallon discharged. So another case studies type system, I wanted to kind of show a couple of projects that sort of broke down costs a little bit better. This is a huge project. They had 8 systems located here, and you can see the lump sum cost there. That was for just the systems and operational costs, pre-treatment. They estimated about 14,400 operational hours, and $6 per hour. And what we've also seen is a big difference in how contractors are charging these operational hours in their bidding during the bidding process. The performance for these systems, and on this project specifically, are typically between 1 and 7 NTU. So in a system that's running properly, meeting that 10 NTU limit that Ecology has is really not a problem. We see most often the discharge is about 3 or 4 NTU. Here's another case study, two-system project. You can see how they kind of broke down the costs a little bit differently as well. And again, you know, based on your project needs, these costs can be broken down differently. It's really hard to make general guidance about how a project should break down these costs. It's really up to what the project needs. So some basic cost-saving strategies: always start planning and design early. Do a project-specific risk analysis, again, soil type, topography, climate. Specify quantitative estimates rather than lump sum estimates. We've really seen that there's a lot of cost savings there. There's really too many unknowns for a contractor with a lump sum estimate. It's really important to sort of break down those known costs. Flow-through systems minimize the need for temporary storage needs, and that simply means that in Washington we are allowed to use sort of passive batch treatment style systems with chitosan, but they're really inefficient if you have large amounts of water. So what WashDOT has always used is these flow-through systems where you're continually bringing water in through the system and discharging. And again, limit the need for pretreatment by using effective source control methods. And for additional information, I've provided a couple websites here. Department of Ecology has a pretty helpful BMP 250 that describes chemical treatment, sort of the design factors that you want to consider when you're going to be implementing chitosan enhanced sand filtration. So it's a pretty good guidance for folks. And there's also some documentation for the general use level designation and criteria in Washington that gives you a little more details about how you actually apply those out in the field and what you're required to monitor and sample for. And that's it for me.
Okay, well, thanks a lot, Elsa. That was great. And again, as a reminder, we're going to do questions at the end, and I can see questions already coming in now. I've just put up, and we'll have a PDF of this up so you can get those web links if you're scrambling trying to copy those down. This is just the poll that I showed earlier, just to let you know, folks that are at the different sites. And then I've got one more question I was going to put up here for you. So this has to do with what disciplines or responsibilities folks have within their department. So I thought we'd take a look and see who we got here on the line. So I can see people are voting. That's good. So I'll cut it off maybe at about 80% or so. Looks good. All right, well, I'll close the poll and just share the results with you so you can see there that well, there's a variety of folks, and that's because there's a number of folks, as I showed earlier, where you know, different people might be in the same room there. So with that, I was going to now turn it over to David Harris, and you know, Elsa gave a great talk on active type systems and what you might apply, particularly under stringent numerical limits that you might have for dealing with endangered species issues like salmonids. And David now is going to talk about a more passive approach and what North Carolina is doing to try to improve the performance of their erosion and sediment control program. So take it away, David.
All right, if you can put the slides back up. I still have the poll on. All right. Thank you to Eric, Elsa, Jesse. Thank you for allowing us to have an opportunity to talk about North Carolina and some of the challenges that we face here in our state. As you can see, North Carolina NCDOT is required to maintain all of its 80,000 miles of state-maintained highways, 15,000 miles of primary and 65,000 miles of secondary roads with about 13,000 some bridges statewide. Because we have so many different needs to build, design, repair, maintain, it creates some unique challenges. Our projects are typical of any DOT. We have our big urban loops. We've got our widening projects, our rehabilitation projects, bridge and culvert projects. We've started toll roads here in North Carolina. We have not typically been a toll road state, but recently, due to funding, we have found a need to expand into that area. And then one area that creates unique challenges for us is our secondary road construction. We have a lot of those in the mountains of North Carolina, all the way down to the coastal areas of North Carolina. Because we have this unique challenge, North Carolina Department of Transportation has been given, as my slide advances, has been given a delegated erosion sedimentation control program. This is a little bit different than what a lot of states have to deal with the SWEP. We are delegated the authority to design, implement, evaluate, and modify our own erosion sediment control plans. Now, this authority has been given to us by our State Department of Environment and Natural Resources section. And that is given authority by the Sedimentation Control Commission that was granted in the 1973 Sedimentation Act. Still waiting on the slide. These are the two acts I mentioned, the North Carolina Sedimentation Pollution Control Act and the North Carolina Water Quality Standard. One regulates the sediment discharges from a project, and the other one regulates the water quality. The North Carolina Sedimentation Pollution Control Act is unique in that it governs the basic overall activities that surround any type of construction activity. This one here regulates basically sediment, limits the exposure of areas you have, controls surface water, requires you to have a plan, and manage stormwater runoff. The North Carolina Water Quality Standard is basically we are required to not impact the receiving bodies waters of the state by 50 NTU for standard streams, 25 NTU for reservoirs, and 10 NTU for our trout streams up in the mountains. Now, when we started all of this, we like most states, had our passive treatment BMPs, and the law required us to look at, require us to have a plan using standard BMP methods. But what we started noticing as we used them throughout the 1980s and 1990s, a typical scene was what you see here before you, where we had failures and blowouts. Sediment was being deposited into jurisdictional areas. The regulatory authorities were citing us for notice of violation. So we decided that the BMPs that we were using, we started questioning how efficient were they. Really, at that time, no one had looked at that efficiency and wondered if the devices that we were being told to use, were they really working. So we did probably the best thing we ever did was we went to NC State and began work with Richard McLaughlin of the Soil Science Department, where just about every bit of this information in my presentation is a result of the research work that he and his staff and the university has done to date. When he looked at our standard BMP devices that we have on most of our linear projects, the results indicated what we expected. The efficiency on most of those devices were less than 60%. Now, for a Sediment Act that required us to control everything coming off our sites, it was difficult to say we were going to be ever successful unless we started to improve our BMPs. So we started looking at our discharge points. Land quality, the section in DENR that regulates the Sediment Act, requires us to trap the sediment in sediment basins and other devices. And when we started looking at those traps and sediment basins, we started noticing how inefficient they were from the standpoint of just controlling the sediment that went in them and settling them out. Dr. McLaughlin and his staff found out was due to the turbulence of the water coming into the basin. The turbulence never allowed any of the particles to settle out. We began experimenting with several baffle systems. Many of you have seen probably the silt fence baffle systems, but the one that we settled on, it seemed to show the most promise, was a porous baffle system. This is just a standard core fiber matting stretched over a wire with silt fence posts holding it up inside the baffle. And what this does is it works sort of like a manifold. As the water comes into the basin, this creates a settling and calming effect, which allows the particles to settle out. As a result, the efficiency in our chambers, as we saw the water pass through, grew and grew until we realized this is the direction we needed to head. The second area that we started to look at was how are we constructing these basins? How are we constructing our diversion ditches? I think this is probably one of our biggest areas we were losing sediment in our system. Vertical side slopes, unstabilized entrances was the typical. Dr. McLaughlin started showing that if we would go ahead and create non-erodible side slopes, protected inlets into the basin, and basically stabilize the weir sections so that we wouldn't have any erosion occurring into the basin, our efficiency started to improve because at that point we were only treating the water that was coming from our projects and not what was actually falling in from the sides of our basins. The third area that we started looking at, because we had traditionally used the rock devices, rock dams, we started looking at surface outlets. Now this included skimmers, flashboard risers, and even broad-crested weirs. What we found out was that by taking the water from the top, we were improving efficiency even further. Now, due to the fact that we started using the skimmers, our basin sizes started to increase dramatically to hold enough water to allow for the proper settlement of these particles. Due to the larger basin sizes, we started seeing greater efficiencies. The fourth area we realized we had to make some changes was how fast and quickly we could stabilize areas. Since we were really seeing these areas anyway, we used the traditional straw mulches, which caused a lot of erosion, a lot of turbidity issues. So the department has switched to more mattings, hydromulches, and other modern technologies to try to stabilize these areas as quickly as possible. Our systems work the best when we can prevent the source from ever creating any sediment loss. Now, it was a challenge as we went across the state as our engineers and contractors started to realize the benefits of stabilizing slopes and getting them done quicker. But over time, they started realizing that if they take and finish areas and get them stabilized, these areas no longer had to be worried about as from a contractor standpoint. With all these benefits, we started noticing and realizing efficiency ratings above 95%. Our sediment trap was becoming something that was we could rely on it during heavy rain events. But the one thing we started noticing, this was about in the early 2000s, was when the turbidity issues were rising around the country, our turbidity levels still were not going down. As a result, we went back to Dr. McLaughlin and his staff, and they began to look at how could we control turbidity systems using the BMPs that we've just done. Out at the NC State University, Dr. McLaughlin and his staff have a research facility where he does and conducts a lot of training on these techniques. So if you're ever in North Carolina, and I'll include a link to Dr. McLaughlin's website, encourage anybody to go by there and check out what he's doing there. I really think it's beneficial, and especially for North Carolina, it has made a big change. So as we looked at our BMPs and we tried to figure out how could we take what we've learned and try to reduce the turbidity, we turned to look at what the problem was. In North Carolina, where we have a lot of colloidal clays, North Carolina is famous for its red clay. As you can see here, in our sediment basins, with the fine clays that we have, you could see basins sit for 30 days without any turbidity reduction. So we were going to have to find some sort of solution to remove these suspended particles, and flocculation was about the only way. Trying to find a system that we could incorporate led us to polyacrylamides. Most of you are familiar with polyacrylamides. Dr. McLaughlin began research and looking at ways we could incorporate polyacrylamide into our system. By using fiber check dams or other devices with the fibrous mattings across them, we found that the polyacrylamides showed a dramatic increase at dramatic effectiveness at reducing turbidity. As you can see here on some of his samples that he's run, typical DOT standard basin in the early days was about 8,000 NTU. As we employed our new BMPs, we were seeing stuff drop down to 376, and with the inclusion of the PAM, we were seeing stuff go to 62 NTU. So we were starting to see great results. And one of the things he shows out at his research facility is you can see the turbid water as it goes through this series of treatment train. He tries to simulate how we're going to incorporate the polyacrylamide on a typical construction project. By the end of the run, after he's applied the polyacrylamide, we see a dramatic increase. As you can see here, our traditional devices, which were rock check dams in the ditch, versus a rock and fiber check dam with polyacrylamide, and finally the Excelsior or fiber check dam with polyacrylamide. As you can see there, the turbidity dramatically reduces. So with the polyacrylamide that we used and adding this to the BMPs that we enhanced through efficient methods, we were starting to reach goals and targets. This was about the time when the ELGs started to come around, so we thought this is going to be probably the best direction we could go in. As you can see here, we have our details that we give our contractors. We put about 2 ounces of polyacrylamide on the top of the fiber check dam with about 1 ounce in the front and 1 ounce in the back. Running it down the ditch line, we're able to get it incorporated by the time we get it to our basin. Now, using all the BMP efficiencies that we had discovered through the research with the polyacrylamide, we were starting to see our turbidity numbers drop down below the 100 NTU range. But with like anything else, they're not perfect. We see installation errors, plan errors that we have to address in the field, and the occasional blowout that still loses sediment. A passive system does take up a large footprint, as you can see here. We did use a lot of sediment basins on our projects during construction, and we route that water through diversion ditches and other berms, and we treat that water as the project progresses. But in North Carolina, like any state, we have our challenges. In the mountains along secondary road construction with narrow right-of-ways and rocky areas, it's very difficult to even construct a basin of any sizable dimensions. In the east, where everything is coastal wetlands and protected marine life, these areas also create new challenges. And with topography and urban areas around the state, it takes some planning. Now, the way we've been successful here in the state is through these 4 areas: training, design, implementation, and monitoring. We used NC State again to develop a training program where it involves 3 levels of training that we send DOT staff and the contracting staff to, that helps them learn what we're trying to do out there, teach them how to handle and manage the plans, and how to design erosion sediment control plans. Followed up with implementation and oversight. We have crews out there that know, due to their certification, are installing our devices correctly. And with a series of checks and balances and staff, we are constantly monitoring these devices to make sure that they're working. You cannot put these devices in and walk away. Now, we've done several projects with monitoring on them. We've had projects around Charlotte where we've used the automated samplers that sit in the streams, all the way to with the work that Dr. McLaughlin has done, where we've had the ISCO samplers taking the actual samples and take them back to the lab. We've had mixed results using both sampling methods. both methods result in a lot of labor and expense. As you can see here on an aerial photo of one of our projects, as we clear a project out, we should go back and temporarily stabilize these projects as culverts, bridges, and other utilities are moved. Relying on these passive sediment devices, we're able to move through a project like this and successfully keep our turbidity and sediment in check. But as you can see with each orange triangle, these would be areas that would require us under the ELGs to monitor. I think Jesse mentioned it correctly when he said a linear project needs to have a representative sample. But to date, as we've been discussing with the regulatory agencies, we're not quite sure which area would be selected as a representative sample. Some people have come to us and said, well, with the 20-acre limit, you're not going to be affected by that many projects. This is a widening of US 19 in the mountains. And in order to put that curve in, they had to take down the mountain. And that area right there that you see is, it by itself is 20 acres. And when you take borrow and waste areas, we'll be probably exceeding 20-acre limit quite frequently in some of our construction projects. Here are some websites I hope you'll take time to go look at. One is Dr. McLaughlin's website. He offers a lot of information, more detailed information than the information I just gave you on what he found in his research. And then Roadside Environmental is what we do here with our erosion sediment control devices and our special provisions. And if anyone has any questions, wants to ask me directly, I've attached my email address. And with that, Eric, I think I'm done.
Okay, well, thanks, David, and Elsa and Jesse as well. And so now what we're going to do is move into the question and answer period. And again, there'll be a PDF of the presentation on, so if you didn't quite copy down all those web addresses, you'll be able to get to those. So for our question and answer period, again, you can submit your questions via the GoToWebinar control panel. It should be up on your screen. And I'm going to go ahead and actually some folks have submitted some good questions, so I'm just going to go ahead and start with one of those. And I think this actually could go to all of the speakers, but for the question actually came up, I think, during Elsa's talk, but it really hits at all of them. But the question is, for linear transportation projects with limited right-of-way space available, what happens if there isn't enough room to install enough systems and or storage to attain a 10 NTU discharge limit? And that came from a Walt, and I'll hope I'm not hatcheting names here too much, but Walt Dragolowski.
Well, this is Elsa. What happens? Well, I guess the same sort of thing that happens if you're out of compliance with your permit. That is the #1 challenge the linear projects face. And we have had some very small footprints, and we've had that problem. And projects have been pretty creative with the use of Baker tanks and Weir tanks and trying to get these, several different tanks lined up, and creativity is the #1, needed resource. And if you can't do it with that, an active treatment system, hopefully you have some areas for dispersal or infiltration or maybe sanitary. What we've seen a lot as far as space limitations have been often in urban areas, and there usually is some sort of sanitary sewer discharge option. And so, yeah, I can't really answer that question any better than that.
Yeah, I kind of agree with Elsa. I think in most of our cases, we will try to limit the exposure, try to seed mulch stuff as quickly as possible, if not within a couple of days or 24 hours as soon as we can, using mattings, other hydromulches. We have got good results up in the mountains with the wattles, the polyacrylamide in real tight areas. Due to the soils here in North Carolina, the polyacrylamide has been very successful for us and easy to employ. There has been some situations where we have explored basically covering the project up every day and trying to just eliminate that potential for erosion and sedimentation loss.
Okay. I don't know if Jesse, did you want to add anything, or?
No, I think they've covered it.
Okay. And you, Jesse, you're a little bit light on the sound, so you might, when you get to a question here. So, speaking of that, this question actually came in during your talk. Is there any flexibility in the vegetated buffer requirements for linear transportation projects, i.e., bridges and culverts? And I'm assuming the question has to do with you have limited space and all, and as well as you're in an urban environment. And that came from William Cody.
Yeah, there is some flexibility built into the rule, and I touched on this briefly on one of my slides, and we do have some language, and this is particularly applicable to the buffer provisions as well, that it's a requirement unless it's infeasible. So I can contemplate a number of cases, particularly for linear projects and DOT projects, where it is going to be infeasible to maintain that buffer, particularly when you're doing water crossings and bridges and those sorts of things. One thing you might want to look at too is the current EPA permit, which is out for comment. And we do talk about the types of activities where you are allowed to encroach up to the water, water-dependent construction activities, those sorts of things. So I believe there's definitely flexibility built into those requirements that hopefully will alleviate the concerns for some of your projects.
Okay, thanks. Actually, two different people asked a pretty similar question. It was for Elsa, and it was around how does a CESF, Certified Erosion and Sediment F, I'm not sure what that is, technician become certified, and what are the requirements? And Lynn Halliday asked that, and I think Richard McLaughlin also asked that question.
Sure. Well, it's important to remember also that this requirement for the folks to be certified is in the general use level designation documents that are required by the Department of Ecology here in Washington State. So it'll be important to figure out with your local regulatory agencies what those requirements may be. But in our state, to be Chitosan Enhanced Sand Filtration, that's the F, to become a certified operator, you need to have the CESL certification. So it's a 2-day training, in-class and in-field training. And then on top of that, it's about a 40-hour course, and it's an additional 8-hour classroom specifically about how to operate the system, and then 32 hours supervised field work, actually calibrating, starting, stopping, monitoring these systems.
Okay, great. Shauna Kent asked what I thought it's a question to Jesse, but I think actually all three of you could probably respond to this too. But the question is, if background turbidity is not taken into account, how is it handled if the receiving waters already exceed turbidity limits? So in essence, how is that taken into account in any of the limits that are out there?
Right. Well, for the effluent guidelines, it's not taken into consideration. So these rules they're blind to what the receiving water parameters are. It's specifically a limitation on the turbidity that's allowable in the discharge. But in most, if not, I think all areas of the country, there are water quality standards for the receiving water, which dictate what the maximum allowable turbidity level would be. And I know in a lot of states right now, those may be narrative requirements, or they may not. The presumption is that if you're complying with your permit requirements, then you're meeting water quality considerations. So I'd say it's really it's going to vary state to state, but I could certainly contemplate cases where projects, now that they're going to be subject to monitoring requirements, may be subject to more stringent water quality-based effluent limitations above and beyond what's contained in the National Effluent Guidelines.
Dave or Elsa, did you want to chime in? Or?
Well, here in North Carolina, the background levels, the way our Department of Water Quality looks at that is if the upstream side is above their limit, say 500 MTU, because we do have a lot of agriculture going on in our state, as long as we don't raise it above the background level, we don't violate the rule. So if it's 500 upstream and it's 500 downstream, we're okay. But if it's 500 and then 1,000, then we're in violation.
In Washington State, we're held to the benchmarks. They're not limitations, but they are benchmarks that once exceeded require a certain level of action. There is an option in the permit if you exceed the 250 NTU phone reporting trigger that you can continue to, one of the requirements is that you have to continue to sample until the discharge is below 25 NTU, or the discharge stops or is eliminated, or until you can verify that your discharge isn't isn't violating water quality standards. But we do just use the benchmarks as our guidelines.
Okay. There was a couple of folks that asked a similar question to each of the state DOT speakers, Elsa and Dave. And it's around what happens with either the flocculated chitosan or the PAM that settles at the bottom of the sedimentation systems, or is screened out, I guess. So that in essence, what do you do with that? And that was asked by Richard Urpin and Gail Unruh. Question.
Well, in what we do, all of our polyacrylamides that we use have to go through DWQ. We'll take those products and check tox test on them to make sure that they're not creating any issues in the environment. And then all of our application of polyacrylamide has to go through a settlement basin. And that material is then excavated and used on the project in the wasted areas and stuff. So it's incorporated back into the project.
Somewhat similar. In Washington State, we're actually not allowed to apply PAM directly to the water. That's considered chemical treatment. So we would need prior approval from Ecology to do what the folks in North Carolina are doing. But as far as chitosan goes, we are required to contain that flocculated material in a holding tank. It typically is from the back flushing of these sand pods. There is a very thick, gooey sediment material that builds up at the top of the sand pods that needs to be back flushed out of there to clean the sand pods out throughout treatment. And that sludge goes to holding tank areas, and it will settle out, and you will typically get some cleaner water on top that will go back into the pre-treatment ponds. So by the end of the project, you do have a large amount of sludge, and there are different ways of dealing with this stuff. You can take it to a waste location, or you can press the water out of it so you have a really sort of dry cakey material and incorporate it into the site in a location where there's not going to be the possibility for discharge.
Okay, there's a question for Jesse, and this comes from Gail Unruh, and the question is, what are the definitions of infeasible?
Well, that's a good question, and there really aren't any definitions of infeasible. So I think there's going to be a lot of case-by-case interpretation and the need for documentation on part of the contractor or the permittee working with the permitting authority on individual issues if you do want to get an exemption from one of the requirements.
Okay. So I have a question for WSDOT. This comes from Dan Hamlin. And Elsa, you mentioned that contractors bid this active treatment work differently, and you stated that price per gallon may work best. I thought a lump sum payment would be a better approach due to the fact that rainfall events could bump up the volume to be treated, and therefore the price per gallon type of payment could be very unpredictable. Does WSDOT have experience with both types of payments, and could you discuss pros and cons? Thank you.
Yeah, wow. As I said, WSDOT's still trying to figure out the best way to bid these projects. What we have found with lump sum bidding is that there are a lot of unknowns for the contractors, and what we have seen is that we end up paying more for less efficient systems. By breaking up the bid into known costs, it does help sort of keep things under control and measurable. We don't bid. I haven't seen any bids that have said that bid per gallon treated, saying, you know, we're going to pay 5 cents per gallon discharged. What we do is we do a hydraulic analysis and try to estimate the amount of water that we're going to need to have treated. And what we do then is use the type of system. You know, these systems are either 500 gallon per minute discharge, you know, 350 gallon per minute discharge. So we identify what size of system we may need and try to estimate the number of operational hours that we're going to need people out there operating these systems to get rid of the water. You know, you can make an estimate based on the location. Typical rainfall in that area, which is admittedly very difficult, and we do overestimate a bit. But what we're doing when we break down our bids is try to get those known costs. For example, rental equipment, the amount of Baker tanks we're going to need, the amount of piping, whether or not there's going to need to be a remobilization of the system during construction. So we're not breaking it down to the point of saying we're going to need 70 million gallons treated at 5 cents per gallon. We don't get to that level of breakdown, but we do try to identify known costs to try to provide a little bit of more known information to the contractors during their bidding.
Okay. I have a question for both Elsa and Dave, and the question is, what precipitation events do you design for? How do you handle run-on stormwater? So I guess there's two questions there. And maybe, Jesse, actually, you might be able to chime in on these two.
Here in North Carolina, we are required to design for traditional areas that don't have high value 10-year storm events is what we design to. And then for all areas that 303D, high-quality water, protected species, reservoirs, drinking supplies, we're at 25-year storm design.
Yeah, we do the 2-year, 24-hour storm event. That'd be a design storm event. We also are required to have sort of contingency plans, which typically mean some sort of overflow system or additional storage for extreme events.
Yeah, and this is Jesse. In terms of the effluent guideline, the compliance storm event that the guideline is based on is the 2-year, 24-hour storm. So any discharge that results on a day when you have more than that amount of precipitation, you would not need to be in compliance. But we don't go into any specifics in the rule other than that exemption about design size or anything. And then to answer the question about run-on onto the site, yeah, and in terms of the guideline, once the water's on your site, it's yours to deal with. So you certainly would have to consider the volume of run-on that's expected if you're not able to implement diversions or other ways to get that water to bypass the disturbed areas of your site. Then you've got the potential that you might have to consider that volume of runoff whenever you're designing any, impoundments or storage volume if you're planning to do any sort of treatment.
Yeah, so I guess if you had a pipe running underneath the construction project carrying upstream flows, you probably would want to do your best to not have your compliance point be at the end of the pipe, but perhaps inflow into the pipe.
Yeah, it's a possibility.
You don't want to have to take on somebody else's runoff. Right. So this is a question I actually had queued up, and somebody else asked it now for Jesse, but it's basically, can you give me the number? And that comes from Amy Foster, so that would be the turbidity limit that EPA is considering, or some sort of range. That's what you're considering, what she asked.
Right. No, I can't give you the number yet. We're still working on it. It's still deliberative, but I'm hoping you won't have to wait too much longer to see the new proposed rule come out. But I think in general terms, I can say that we're still looking at the same sort of technologies. We're not looking at making the limit, back at the active treatment level, active treatment system level. We're really still looking at, passive technologies, some more along the lines of the things that David talked about in his presentation. So I wouldn't be surprised if it's a little higher. I wouldn't be surprised if we take comments on maybe a range of numbers. So that's pretty much all I can say right now, unfortunately.
Okay, great. So this question comes from Brian Courier, and it's with the Kaidasan system. Have you found it's been, and this is for Elsa, have you found it to be ineffective at times due to water chemistry? And how were those situations handled?
Yes. If there's any PAM in the system that can be a problem, I do recommend, I'm not a soil chemist, but I know it's quite complicated, and I have, when I was actually out in the field operating these systems myself, I have seen differences in treatability depending on the type of runoff. And I do recommend, if you think there's any unique soil characteristics in your project, to have a treatability test done prior to getting a system out there, and that can be pretty simply done by just getting a sample of discharge, or maybe having some soil taken from the project in a jar of water, and having some Kaidasan mixed into it, and see if you get that flocculating effect. There are treatability tests. We have the ability to do that here in Washington before we decide, okay, we want to implement this on the project. First, we want to see if it's even going to be effective at treating our runoff. So that is a recommended step during the planning process.
Okay. This is a question from Gail Unruh. It's to both David and Elsa, and it's, how did the workforce shift at the DOTs to compensate for additional project inspection, sampling, and design for the systems? Or is this all done by contractors? And then the follow-on question to that was, do you certify your own personnel?
Well, I could probably answer that a little better if I'd been at WashDOT more than a year and a half, but I can tell you that we do require our contractors to provide a CECL certified individual to do the weekly inspections that our permit requires us to do at all of our discharge points and installed BMPs and areas that have been disturbed. And we also have project environmental inspectors that go out to take samples at least weekly when there's a discharge. And our folks are now required to also be CECL certified. And so we have had a little bit of a struggle trying to figure out a way to internally certify folks, but we do have a program up and running now where we can certify our folks internally to be able to do that water quality sampling.
Okay. Yeah. In North Carolina, we've been doing our erosion sedimentation control delegated program for years, decades, and have been training staff over the years. And so we have a system that depends on the project engineers, the project superintendents, the contractors, supervisors. We even have a third party from our own units that are field engineers and technicians that go out and do multiple layers of inspections and checks and balances. And then this was sort of taken up a notch when we began to work with NC State in a training program that basically trains the different levels of people that will be out there. And that's probably been our biggest success. And that certification that NC State's doing for us has given a standard across contractors, consultants, and even DOT employees that we've not been able to achieve over the past several decades. So using the varied levels of checks and balances, I feel that we have a very highly trained staff of DOT people, contractors, and consultants out there right now.
Okay, great. So this is a question from Richard McLaughlin for Jesse, and he's wanting to know what the definition is of discharge directly to surface water means, and i.e., if you had a 1-foot buffer, would that still be a discharge, direct discharge?
Oh, that's a good question. Again, I would say to take a look at the the general permit, the EPA general permit that we just came out with, and I think it also sort of harkens back to definitions in the Clean Water Act about what constitutes a discharge. And I think you can look at certain discharge and know that they're a discharge. If there's a pipe going into the stream or a ditch going into the stream, it's pretty clear that that's a discharge. But I think it does get very fuzzy when you talk about dispersed runoff, runoff going through a buffer or even something like a silt fence that really is not concentrated. So. Again, I think this is one of the issues where it's the guideline talks about the types of things we would expect to be monitored, but I'm not sure that there's a hard and fast definition out there that we can provide folks right now with the types of discharges that would need to be monitored for compliance and the types that don't. So I think the hope is that when folks are putting together their erosion and sediment control plans or their SWIPs or whatever the documents are, that the states include some provisions in their permits that has them think about where the water is going and the types of discharges that are appropriate for monitoring and those that aren't. But I can certainly contemplate the need for some additional information or guidance on the part of EPA about the types of discharges we would expect to be monitored, particularly I think from a compliance standpoint. When you have a inspector coming out to your site and he's looking around and you've got a silt fence that's maybe needs some maintenance and it's concentrating the discharge, and you didn't intend that to be a sort of point source or concentrated point where you would be monitoring, but if you look at it, it would certainly look like it would qualify as a point source that would need to be in compliance. So again, I think I don't want to discount the fact that I think there's going to be some growing pains over the next few years as everyone gets used to monitoring and sort of works out the kinks in this process. This is a big change, I think, for most programs, and I think we at EPA are well aware of that. So that's about all I can offer up right now on that topic.
Yeah, I was going to add that in some of the permit hearings in California and the draft municipal stormwater permits, there's been discussion about at what point is impervious area disconnected or not. It's the same kind of an issue of if you put it into some landscaped area that's only a foot wide before it then heads somewhere else, is that disconnected or is it not disconnected? So it's a pretty similar discussion item. So I think the bottom line is it'll happen at the state level for now, right?
Yeah, I agree. But I would also say that again, encourage everyone to look at the proposed EPA permit and look at the language we have in there. Again, the number's not in there because the number doesn't exist right now, but we have tried to address, I think, some of the issues associated with sampling and so forth eventually. And I definitely encourage you to look at that and submit comments, even if you're not subject to the EPA permit because your state's delegated program. I think we would definitely welcome the feedback from anybody on the broad range of topics that we're dealing with for the first time in our permit.
Well, here's another question that might be feedback to you. Is there any provision for exceeding an hourly average of the 2-year 24-hour storm event, such as if you get a 2-hour cloud burst and then get some erosion and sediment control failures without that causing an exceedance for the total event?
Right. That's a very good question, and it really comes down to intensity. I would say, I'll be honest, we struggled a lot with this issue whenever we were crafting the guideline in the first place in terms of what's a compliant storm event and what's not a compliant storm event, and the whole issue of high intensity storm during a short period of time. I think definitely has the potential to overwhelm any level of controls that you have in place. So we went back and forth with this a lot, but in the end we arrived with having it as a total daily precipitation depth, the 2-year 24-hour storm, but we did not include a temporary, so for example, if you exceeded the 2-year 24-hour intensity for some period of time, an hour or 2 hours, to getting an exemption to that, we decided not to go to that with that approach. So for a number of reasons, mainly I think with the with it being more of a volume-based standard over the course of the day, I think that translates easily into providing a sediment basin or an impoundment with that volume of storage. So you size it to capture that runoff, and then anything that in addition to that would bypass or go over the overflow, you would not need to worry about for the course of that day. But when we start talking about intensities, then you've got to get into the issue of having a rainfall record for your site. And so does that mean you have to have a rain gauge installed, and you have to be logging the precipitation data, and then comparing that precipitation data to when your samples were contained. And you could use the nearest airport gauge, but that may be miles away and not representative of your site. So we just saw a lot of issues, potential issues associated with using an intensity as opposed to a total storm depth for exemption periods. So.
I suppose you could also, you think about the BMP types too. Those that have storage involved in them in terms of treatment anyway, they wouldn't be quite as impact. I mean, they might see more of a load coming into the system because of a high intensity event, but they have a volume, that they can capture. So a little less subject to those types of BMPs are a little less subject to the intensity issue.
Right, that's correct.
So here's another good question. I think this applies to the arid states. So I guess, and a part of why, believe it or not, part of Washington is arid. But I think, Jesse, you could weigh in on this one too. I don't think North Carolina is too arid. But what are some of the things that you could see that an arid region would have to take into account differently than a wet region during planning and design? Do you foresee a different type of treatment being needed? And this was asked by Gene Cordova.
Yeah, well, I would say I think the biggest challenge for the arid areas is the stabilization. I mean, we have this concept in there that soils being disturbed and unstabilized really triggers the need to do the compliance monitoring and the sampling. And once you get portions of the site stabilized, or you're under 10 acres disturbed at one time, then you don't need to comply with the numeric limitation anymore. But stabilization in arid and semi-arid areas is a lot different than what we're used to here in Washington area in the Northeast, particularly in terms of vegetative stabilization. So I think that's the main thing that I think is important for the arid states as they develop their permits, is coming up with appropriate language for what constitutes adequate stabilization, not only for triggering the guideline requirements, but also for terminating permit coverage. But as far as the treatment technologies, I think that's a really good question. I'm not aware of much data that's been collected specifically in arid areas on some of the enhanced controls we've been talking about today. So, I can certainly see the concept of planning your projects during the dry season to try and limit your exposure is something that might be potentially important. So, yeah, I think again a lot of challenges, not only to the types of projects but also to the different climatic areas of the country is definitely something that'll we need to work on over the next few years.
Elsa, did you want to chime in on that one? Or?
Sure. In our state, the east side of the Cascades, there's some quite arid regions, and the Department of Ecology's stormwater management manuals, there's actually a west side and an east side version because of the extremes we have on either side of the Cascade Range. And there are some different permit requirements for the different sides of the mountain. The east side has longer timelines for when they're required to cover disturbed oil. We have larger acreage disturbance limitations for the east side. And again, like Eric said, the biggest issue we see over there is the stabilization, how to get vegetation to grow, or how to get the site stabilized once construction is done. We have not seen any active treatment systems installed on that side of the Cascade Range, mainly because when there is rain, typically everything infiltrates, or there's good areas for dispersion, so standard BMPs have been effective over there.
I would just add that in cases where you don't have high infiltration rates, one of the things you'll often see in arid climates is when it's raining, it's pouring, and so you get some higher short-term cloud bursts like thunderstorms and things like that. So
yeah, and we have we have some wind issues over there, so erosion control as far as wind goes is important over there.
Yeah. All right, this next question is back to Jesse, and I guess it's on the proposed construction general permit, and it's from Ronald Tellier. I hope I'm pronouncing that one correctly. He, and I think I know that I'll give the first part of the answer to this, but it says you mentioned special consideration for linear projects, i.e. you might be able to do representative sampling, but in the proposed general construction permit, EPA's that you've requested comment on page 34 says the agency's preference is to limit the use of representative monitoring. So I think the short answer to that is write a comment. So Jesse, I'll let you chime in on that too.
No, yeah, I agree. Write some comments. This is, as you know, the first time we're incorporating any sorts of requirements of this nature in our permits, and I think we, we work together at EPA, but the permitting is done by another group of people, and I know I don't want to speak for them, but I know that they would definitely welcome your comments on this issue and what you feel as the potential permittees about what's feasible and what's not feasible, and what an appropriate level of monitoring would be at your site. So I would say it's a proposal for a reason, and we want to hear from everybody about what we got right and what we didn't get right. So.
Elsa or Dave, do you guys have a representative sampling provisions that you'd want to highlight or talk about, or?
We do not at this time. We are required in our permit to take samples that are representative of the discharge, but it's not the same sort of language, not the same sort of term that the way it's being used as representative sampling locations as it is in the proposed EPA permit. So.
Yeah, we in North Carolina we have talked about representative sample, but it's been difficult to say what is the most important part or what is the most important point on a project or which point is going to be the most representative. And I don't know if that will ever be resolved.
Okay. Well, with that, I think I'm going to go ahead and close the question period, other than if a panelist wants to offer a quick question up to one of the other panelists, we could do that quick, but so I'll ask that question. Or are you guys good to go?
I'm good.
All right.
Good.
Okay, well, just a little bit of a wrap-up slide. Ask you to please fill in and submit an online questionnaire. You're going to get an email that provides directions for that, and we would sincerely like to get input on what you felt about the presentation today, and also ideas about upcoming things you'd like to see discussed. We will have the webinar available for on-demand viewing, and actually a couple people asked a question about how to get the PDF of it. So we'll have both the webinar where you can actually listen to it and view it, as well as download a PDF of the presentation. That'll be available probably mid to late next week at the website that's up there on the screen. And then, as I mentioned earlier, please look for future announcements about the upcoming webinars. And then finally, I just want to thank you all for your attention and participation and the great questions. And I'll look forward to the next one of these, which I mentioned would be in the June time frame. So with that, I'll say goodbye to everybody and have a good rest of your day. Take care.